needed for this experiment are some pepper clips and bobby pins, heat source. In our experiment, we use cooking stove as our heat source, ice water and pliers. Then on the gas stove, heat the loop of a bobby pin red hot and slowly lift it out of the flame. Try to pull the bobby pin to detect the deflection. Now, let's try it with a pepper clip. Repeat the steps using a pepper clip. This is the result after hitting the bobby pin and the pepper clip and slowly lifting it out from the flame. Heat the bobby pin until it gets red hot. Put it in the ice water. Again, heat the bobby pin in the top flame for a few seconds, but this time don't heat it until it gets red hot. Slowly pull one of the end part of the bobby pin to see the deflection. Repeat the steps with a pepper clip. Scientific explanation. These are the hypotheses of this experiment. Steels will behave differently towards heating since it is an interstitial alloy. Bobby pins and pepper clips are different type of steel since their reaction towards heating will differ. Iron is electroplate, so it is divided into two structures which are BCC and FCC under certain temperature. These are the results of this experiment. Statistics. Bobby pins and hair clips are processed in much the same way but contain different amount of carbon. Bobby pins and hair clips are formed from cold worked steel wire. Paper clip containing little carbon and it is mostly pure with some iron carbide particles. And lastly, bobby pins has more carbon and contains larger amount of iron carbide, which makes it much harder and stronger. Additional information. Why steel is affected differently by heat treating? For your information, there are few reasons. Firstly, iron is electroplate. The FCC is above temperature 912 degrees Celsius, while BCC is under temperature of 912 degrees Celsius. Secondly, steel is an interstitial alloy. Most other alloys are substitutional. Third, FCC is more tightly packed than BCC, but it has larger individual caps. Fourth, annealing is like what happened with copper. There is crystal regrowth and dislocations are decreased. The metal is softened. Fifth, quenching causes steel to become very strong but also very brittle. It forms an intermediate crystal structure which is metastable and extra stress in the crystal. And lastly, tempering is a secondary heat treatment. Strength is maintained while improving toughness. It removes some of the brittleness and remains body centered tetragonal.